everyone, welcome to the official YouTube channel of Coding Club RVCE. Today we will be discussing the second problem of LeetCode Contest number 382. Let's start off by describing the problem. So we are given an array of positive integers and we have to return the length of the largest subset that can be formed and which follows the pattern of x comma x squared all the way to x to the power k by 2 x to the power k, where k is the power of 2, then the pattern repeats itself. So x square is the length of the largest subset which follows this particular pattern is to be returned. So what particularly is a subset? Suppose I'm given the array like this. One possible subset can be 7, 3, 9. Note that while devising the subset, we neither consider if all the elements are considered, neither do we consider the order in which the elements appear. So now let's dial on some test cases first. So 5, 4, 1, 2, 2. A possible subset for this array will be 2, 4, 2, which follows the pattern as it can be expressed in this form and has the length of 3. And we can observe that no other subset is present which has a length greater than 3 and follows this pattern. Now let's consider another example. 1, 3, 4, 2. The possible subsets which can be generated and follow the particular pattern are 1, 4, 3, and 2. All are length 1 only. So the maximum length will be 1, and that will be the final answer. We have to be careful of 1's though, because 1 raised to any power will be 1 itself. So 1, 1, 1, 1, 1, 2. In this case, 2 will be 1 and it satisfies the pattern. The subset 2 will be of length 1 and satisfies the pattern. And then the subset 1, 1, 1 satisfies the pattern and will be length of 5. So the maximum will be 5 and our answer will be 5 itself. Now let's try to revise an algorithm. So for that, let's go to this case. Now, since in a subset, we are not bothered about the order in which they occur in this problem, it's enough for us to consider the frequency of the various elements. So what we can do is we can start from the smallest one and we can keep on checking whether it is the frequency of that is greater than or equal to 2. If it is greater than or equal to 2, let us continue to square the element, and then let's compare it again of the particular element. Means the square of the element, we will check whether it is also present more than 2 times or 2 times in it. Once we encounter that it is not present more than 2 times, then either it will be present once or not present at all. If it is present once, we should just add 1 more to the counter, which we keep incrementing by 2, and then we should return. However, if it is not present, that means that this particular element wasn't present. So we should just consider till here, and this element also goes off because we should have only 1 copy of the maximum element. So after k to the power x by 2, the next element will be k to the power x by 4, and so on. So we have to subtract it by 1. So let's take an example and better understand this. So 5, 4, 1, 2, 2. First of all, we will consider frequency table. So 5, 4, 1, and 2. So this will be 2, this will be 1, this will be 1, and this will be 1. Then we will first check for 1. 1, we will check whether it's present greater than or equal to 2 times. For 1, actually, we will have a special test case. Let's not bother about that. So 2, we will check whether it's greater. The count of 2 is greater than or equal to 2. Yes, it is. So then we will square the element. After we square, we get 4. So we check whether the count of 4 is greater than or equal to 2. Since it is not greater than equal to or equal to 2, we will come out and we will check whether it's equal to 1. Since it is equal to 1, we will just increment the counter by 1. The counter initially will be 0. Since it identifies 2 to be occurring more than or equal to 2 times, we will increment it by 2, and here we will increment it by 1. We increment it by 2 because it occurs twice in the subset. So the obviously it contributes 2 units to the length of the subset. Now let's try to understand the code. So in this particular code, we have created an unordered map to keep an account of the frequency. The frequency table is created using it, and then set so that we can avoid excess iterations. And we have made a long square variable to square the element each time for the next iteration to check its frequency. Then the answer to store the length of the subset generated. Now and count is nothing but the it for each element, for each subset generated when slicing of the elements, it creates a partial initial answer, which is then checked whether it's greater than or equal to answer, and the maximum of the word is placed into answer. Now let's check this for loop. First, we are creating the frequency table, and then we are inserting the element into the set. Then for each element in the set, if it is 1, the problem with 1 is 1 raised to any power will be 1 itself. So this while loop will be an infinite loop, so we can't consider it because the frequency of 1 remains constant, whatever you do. So for this, what we can do is, as we had discussed over here, we will calculate the number of frequency of ones. It can be positive or even. It can be even or odd. When it is even, we have to subtract 1 from it. Since we cannot have these two like this, it occurs in pairs, and at the middle one, it stops as a singular element. So we have to subtract 1 from it. However, if it is odd, we can just return the count of ones. So if A is equal to 1, the count will be nothing but the frequency of 1. And then this is a sugar code for subtracting or keeping it same depending on whether it's even or odd. Then this else condition else statement handles the other conditions, in which first we assign A to the square variable, and then we check its frequency. If it is greater than or equal to 2, we increment the count by 2, and we square the particular element for next comparison. And then we again check its frequency. And if it is greater than or equal to, we keep on repeating it. Once it is not equal to 2, it will come out of the loop, and it will check whether it's equal to 1. If it is equal to 1, we will increment it by 1. Or else that if it is not equal to 1, that implies that the element wasn't present over here. So we have to reduce the array and eliminate this as well, because we can only have one copy of the maximum element. And then we are just updating the answer over here. So let's test this case now. Test this program now. Yeah. So it is accepted. Thank you.
coding club.